What's up guys, it's Mars from Audio Judgment and today I'm going to teach you how to design a bass reflex box. And if you think that it's too complicated, well, you're wrong. I don't care how low is your level of understanding, if you have some basic math skills and finished watching this video, you're going to be able to design a ported box by yourself. First of all, if you want to learn more about the ported box, you can check out this video. I'll link it in the description. But now I'm going to show you how to design a ported box. If you're wondering why my method is super fast and easy to follow, it's because we are going to use Excel spreadsheets. If you are familiar with my style or watch any of my courses, you'll know that I like Excel spreadsheets. And I made one for designing bass reflex boxes. The beauty of it is, you just enter 3 parameters and it calculates the box volume and tuning frequency. Even though I have a lot of apps for speaker design from simple to complex, I still use this spreadsheet because it saves me time. So for example, if I'm searching for a driver, I can quickly check in the spreadsheet how large the box needs to be. If you have any concerns about the accuracy of the spreadsheet, at the end of the video we will compare it to WinISD and check the results. To get the spreadsheet, you can check the video description for a download link. And now before we open up Excel, let's stop for a moment and think what we need to calculate. It's only 3 things. The internal volume of the box, the area of the port, and the length of the port. If you got these numbers, you can go ahead and start building the box. So let's open up the spreadsheet and I'll explain things as we move along. First observation. The spreadsheet has multiple worksheets. You can see here sealed, which I covered in a previous video. If you want to design a sealed box, you can check out that video. And depending on which units of measurement you prefer, you are going to click the appropriate tab. This one is for liters and millimeters, and this one is for cubic feet and inches. The same thing goes for bass reflex boxes. What concerns this video, I'm going to use the metric system, so liters and millimeters. Before I click the bass reflex tab, there is another tab which pretty much serves no obvious purpose. The bass reflex alignments tab. If you click it, you will see this table full of numbers. These are copied from the loudspeaker design cookbook and are simply here to be used when calculating the appropriate volumes and tuning frequencies. Now, don't get stressed out, I know you got intimidated by this wall of numbers over here, but I'm going to say a few words about the alignments because they are not that difficult to comprehend. So here's an explanation. Basically, a speaker has a lot of parameters, one of which is QTS. If QTS is between certain values, then that speaker is eligible for particular alignments. You can think of alignments like presets that will give certain sound signatures which are desirable. Now, if you read the loudspeaker design cookbook and got to this section, you probably got frustrated. No one likes to see wall of numbers, and also check out the names of these alignments. This is SBB4 or 4th order boombox. This one over here is QB3 or 3rd order quasi Butterworth, and this one is SC4 or 4th order sub Chebyshev. But don't worry, you don't have to remember anything, you just have to know what response they achieve, and if you are after that response, you can pick that particular alignment. So for example, SBB4 is an alignment which will result in a response which is very similar to a sealed box. It has a very smooth roll-off and very good transient response. QB3 is the maximally flat response, usually called Butterworth response, and for all intents and purposes, this alignment is the one which people will aim for. If your particular driver has a high QTS, you might consider the SE4 alignment over the QB3. Now that we finished talking about the alignments, let's start designing a base reflex box. So let's click the base reflex tab. And if you are not familiar with my spreadsheets, what you need to know is that in the orange cells, you will input data. If it's not orange, you leave that cell alone as it might calculate something and you can mess up the formula. Now, up top, we got the speaker parameters and we only need 3 of them: FS, QTS, and VAS. Let's open a spec sheet of a random subwoofer and look for these parameters. So I chose this peerless 12-inch subwoofer, and we just copy the 3 parameters in the Excel spreadsheet. So we have FS of 21.55. The QTS is 0.39 and VAS is 136.04 liters. Up next, we have the box parameters, and we can input whatever box volume we want and tuning frequency. What concerns the parameter in the middle, QL, it refers to box losses. Now, this is an optional parameter. Some modeling apps don't even mention it. It indicates the leakage of your box. If you have a leaky box, QL is low, like 3. Normal losses, QL is around 7. And low losses, QL is about 15. To be honest, box losses cannot be predicted and can only be measured after the box is made. So I don't know why I complicated this spreadsheet with this extra parameter. Just enter 7 here, which means normal losses. Now let's come back to the idea of alignments. You can see in this section that we have the box volumes and tuning frequencies for all 3 alignments. Please look only under QL of 7. So here for SBB4, here for QB3, and here for SE4. We can see that all 3 alignments are available for this speaker. If I start increasing the QTS of the speaker, so let's say 0.50, 0.6, 0.7, 0.8. At some point, some alignments won't be available. So depending on your speaker, you can or cannot use certain alignments. However, 90% of the time you can use all 3. So let's switch to the correct QTS, which is 0.39. So basically what I recommend is to copy the QB3 numbers, so a box volume of 110.6 liters, and the tuning frequency 22.27 Hertz. As you can see, the response is very flat, which is a good thing, and this is the response people should aim for. Now, let me give you an example when you would want to choose SE4 alignment over QB3. Let's make a scenario where your driver has a high-ish QTS value, like 0.55. Let's enter the QB3 values. Not only this box is stupidly large, 2500 liters, the response has this huge peak right before roll-off, which defeats the maximally flat response thing. Problem with this alignment is that it tries to keep this line as flat as possible until it can't, which is right before roll-off. However, if you enter the SE4 numbers, we can see that the response is much flatter. Only difference is that there is a slight deviation here, and here is a slight dip. What I mean is that for higher QTS drivers, you should probably pick a sealed box. But if you insist in a base reflex, it would be wise to choose the SE4 alignment. Now let's switch back to our driver. So QTS of 0.39, and let's go back to the maximally flat response. One thing to note is that these alignments are not set in stone, and you can choose whatever box volume and tuning frequency, but they are a nice starting point. So for example, a 110 liter box might be too much for you. In that case, we can make it a more decent size, let's say 60 liters. As you can see, we lost some of the very low frequencies, so there is a trade-off for making the box smaller. And you are the one to decide if you want to make that trade. Furthermore, if we already lost some of the low frequencies, we might choose to tune the box higher and see what that does. Let's say 30 Hz. As you can see, we start to get this peak right before roll-off. Ideally, you don't want this peak to exceed 3 decibels. Here it's only 2 decibels above linear response. Also, if we look at F3, which indicates the lowest frequency the box will play in a linear fashion, we can see that the box will play down to 30 Hz, which is pretty good. In that case, let's decide on these numbers: box volume of 60 liters and tuning frequency of 30 Hz. Now let's move forward to the port. This is the only noticeable caveat of this Excel spreadsheet. It doesn't calculate the air velocity inside the port, and there is no way to tell if your port is undersized. However, having a large port is always beneficial, so even though we don't know the precise air velocity, we are going to go for the maximum diameter possible. There is a limit. As you increase the diameter of the port, you need to make it longer to maintain the same resonant frequency of the box. Let me show you. If I use a 3-inch port, which is 75 millimeters in diameter, so one port of 75 millimeters, the length needs to be 191 millimeters. If I want to use a 4-inch port, which is 100 millimeters, the length needs to be 364. So as you can see, the larger the diameter, the longer the port needs to be. And since we have to fit this port inside the box, you can imagine that there is a point where the port is so large that it doesn't fit inside. The next size is 6 inches, so 150 millimeters. And that needs to be 873 millimeters long. And good luck fitting that inside a 60-liter box. So basically, we found our limit. We need to use a 4-inch port. If you want to be on the safe side, you can use 2 ports. So 2 ports, 100 millimeters, but those need to be 800 millimeters long each. So one is 800 millimeters and the other is the same length, 800 millimeters, which would also be a challenge to fit inside, probably impossible. So that settles it. The port is 100 millimeters in diameter and 364 millimeters in length. However, using a rectangular port can solve this issue. If you have a powerful subwoofer with high excursion, you might get the feeling that a 4-inch circular port might not be enough and you might encounter port noise at high volumes. In that case, you should use a rectangular port. This isn't the case because this is an 120 watts woofer, so a 4-inch port will be no problem. But let's see how to design the bass reflex box using a slot port. So since this is a 12-inch woofer, let's say that the height of the port is 300 millimeters. And let's select the 50 millimeters in width. Conveniently, I placed an equivalent diameter calculator. This tells us that this rectangular port is equivalent to an 138 millimeter diameter circular vent. So this is much better than a 4-inch port. And finding the space for this port inside the box is much easier by using some L-shaped design. So if we draw a conclusion, we have a 60-liter box tuned at 30 Hz, and the port is a rectangular port, 50 millimeters wide and 300 millimeters tall. Now, because the port is fitted inside the box, it will take up space, and we need to account for that. So we need to calculate the volume displaced by the port, and if this is a slot port, which is taking advantage of a side panel, you can calculate the volume this way. So let me bring up the calculator. You got the thickness of the panel plus the width of the port. So let's say 22 plus 50, and this is equal to 72. And if we multiply this by the height, 300 millimeters, and multiply it again by the length, which is 728. The result we divide by 1,000,000, and there we have the volume displaced by the port, which is 15.74 liters. However, like I said before, this is a low power subwoofer, so there is no need to use this rectangular port, as it takes so much space and it will make the box larger than it needs to be. So let's calculate the volume displaced by the circular port. Let's work with our number. So we have 100 millimeters diameter with 364 millimeters in length. And let's open again the calculator. So we have half of the diameter, which is 50, and we multiply it by itself. And then we multiply it by pi, which is 3.14. And this number we multiply it by the length of the port, which is 364. And again, we divide this by 1,000,000. And we have 2.85 liters. Also, if you plan to place the speaker driver with the magnet inside the box, then you have to add the volume displaced by the speaker. You usually find this in the spec sheet of the driver. However, if we look at our spec sheet, we do not find this number, so we have to approximate it. And I'm going to approximate it at around 2 liters. So our final box needs to have 60 plus 2.85 plus 2, which is equal to 64.85 liters. If you are placing any bracing inside the box, you have to add the volume displaced by the bracing also. So the results are a box with a volume of 64.85 liters, with a circular port of 100 millimeters diameter, and the length of 364 millimeters. A question that might pop up is, where do I place the port? You're going to place it to whatever panel is convenient. For example, if you are making a subwoofer for your car and the box will rest against the rear bench, don't place the port on the back panel because the port will be choked. Rather, place it on the front panel or on the side panel. The top panel is rarely a good pick, as dust can easily set inside your box through the vent. Another thing that you want to consider is inside the box, the port needs to have sufficient clearance. As a result, the end of the port must not be too close to an opposing panel. How far, you ask? Well, it depends on the size of the port. If in this case we have 100 millimeters diameter port, make sure to have at least 100 millimeters of clearance. One other question that might also pop up is, what if I have 2 speakers, not just one? Well, in that case, when you enter the parameters, FS and QTS will be the same, and just double the VAS value. In this case, we have 136.04, 136.04 multiplied by 2. This is the new VAS number, 272.08. Or simply you multiply by how many speakers you have. In this case, if you have 2 speakers, we double the VAS value. And now you are designing a box for two identical speakers which will share the internal volume. Now let's verify the accuracy of the Excel spreadsheet and let's compare the results with the WinISD. So before we start WinISD, let's switch back to one driver. So the VAS is 136.04. And now we can open WinISD. And if we look into the database, we can search for our peerless driver. I want to show you that here we have all the parameters of the speaker, not just those three. And if we start a new project, let's select the driver, peerless. Okay, so one driver, enter box, and let's rename it base reflex. Okay, so now let's enter the parameters of our box. So we have a 60-liter box, which is tuned to 30 Hertz. And if we look at the graph, let's look, we have a peak at around 40 something Hertz of 2.5 decibels. And if we look on our graph, 10 Hertz, 20, 30, 40 something Hertz, we have the same peak over here. If we look at the F3, which is 30 Hertz, this is this point over here, minus 3 decibels. If we go down here at minus 3 decibels, we can see it's precisely at 30 Hertz. If we go to the vent and enter 10 centimeter diameter, the length needs to be 362. And our Excel spreadsheet, 364, which is basically the same. If we choose a rectangular shape, the vent 5 centimeters wide and 30 centimeters tall, it has to be 729, which is precisely the same. As you can see, we get the same results. So don't be fooled by the fact that we input just 3 parameters and in WinISD we enter all of the parameters. As this video comes to an end, we can reiterate the steps. So first you have to enter the parameters of the speaker. Then you will enter QL of 7. Then you can copy the box volume and tuning frequency of whatever alignment you like, preferably QB3. If you are satisfied with the numbers, you can leave them as it is. If not, you can fiddle with the box volume and the tuning frequency. Then you have to choose whatever port you like, circular or rectangular, and go as much as you can in diameter. The higher the diameter, the better, until that port will not fit inside the box anymore. Then you will calculate the volume displaced by the port and by the speaker and whatever you place inside the box, and add to the previously calculated volume to get the gross volume. And when you have the gross volume and the size and shape of the port, then you can easily calculate the panel dimensions of the box and build the box yourself. Now I know that this might be a longer video, but hopefully now you know how to design your own base reflex box. Make sure to give this video a like if you learned something new, subscribe to the channel to see more videos like this, and I'll catch you in the next one. Peace!